Okay, let's start. Can you hear me in the last row, or should I use a mic? Good, thank you. So, welcome to my presentation, React.js, the Domino way, high-performance client for Domino. Before we really start, thanks to the sponsors. They made it available that we can take part here for just a little money and have a great conference. My name is Knut Herrmann. I'm from Germany. I'm a senior software architect at Leonso GmbH. I'm a part owner of Leonso GmbH. We started the company 6 years ago, and we do a lot of consulting, development in the area of Domino and web development. I am Knut's developer since version 2, release 2, and the last years mainly more a web application developer. And some of you might know me from Stack Overflow. There I answered approximately 700 questions. So that was one of my hobbies, or is. And I'm an IBM champion 2018. So, why React? Let's have a short look into the history. The classic Node's development is a Node's client, has a Domino server, and the Node's client, and if we start an application and a database, then the code gets transferred to the Node's client. It's get cached in the cache indicate, and from there on, it just talks data between client and server, just data with RPC. So this is very fast. If you look at the view, you scroll to a view that's working very well, because it's just exchange the data between client and server and no code. Okay, so the next step was then for web development to use X pages, and we have then developed an X page on the Domino server side, and the page gets rendered completely on the Domino server side. That means the whole HTML, JavaScript, and data put into an X page, in a rendered page, and sent to the browser. And the browser does nothing to show it. There is a little bit Dojo stuff included, but yeah, that's it. So it's more into the browser, and the server has to do all the work. After some development, we recognized X pages is not really good to keep all the business logic, and so we moved the business logic into Java, and just the UI components got rendered with the X page. And then from the UI perspective, it was not enough, so the user demanded better look and feel, so we had jQuery, and I had a lot to do with JQuery. That was a nightmare to develop all the nice grids, and select 2 for the select boxes, and bootstrap. So we have now a real mix of stuff we develop for the server side with X pages, with Java, and they are kind of included in the Domino design. We have all this client stuff too, and gets very fast messy, the whole thing. And so we looked for something else. And that was that we have a clear separation of UI and backend, and that we do still the Java code with a little X page, but we wanted something to use in the browser for the UI. And the browser nowadays are so fast that they can do a lot of work and do the work usually with the server on the client side. And so we have a separation on the client side UI, and on the server side web server and database, and they talk JSON with each other. So get data with JSON and we send data to this. Okay. And for the client side, there are a lot of good tools, and we had to decide for one of them, AngularJS. So it was about 2.5, 3 years ago. We had to decide. AngularJS was the top framework at this time. It was a version 1, run very well, but then they changed it to version 2, and they were not compatible. And so there was a lot of anger in this community because they had to rebuild all of their application if they wanted to shift to the Angular 2 and following. At this time, Vue.js was there yet, but not so famous, and React.js was the new large thing in this area. Now, Vue.js and React.js are on the top. If you look at the stars at GitHub, so everyone can give stars, and they both have over 100,000, and Angular is about 60,000 or so. So yeah, we had to decide, and we decided for React. Why? Because React delivers a very high performance on the client side. It allows to build reusable components, so it's all about components, and you can build them a way that you can reuse it in the same project or in other projects. It's a very readable declarative code. We will see that later. And one important thing was that it was developed by a large company, Facebook, and they used it on their own, and they published it as open source at this time, 2014 or so, and made it available for everyone. Facebook benefits from it too, because there is now a large community using the React and delivering things back. And so far, I have to say, every update of Facebook was manufactured very carefully, so the old code doesn't break. That is not normally in the JavaScript world. So if you do an update for such a module or so, it often happens that your code doesn't work anymore, so you have to look into the things. Okay, we used it. Of course, Instagram, because that's from Facebook, that was their first project, and they collected a lot of experience in this and improved React from there. Airbnb, also Uber, are famous platforms. So if you used Airbnb, you get a feeling how it works, and all the others. So Docker is built on React, Dropbox, many others, Netflix. So what is React? It's just a JavaScript library. It's quite small, and it's not a complete framework. So Angular is a complete framework, so you have this one package and you use it, and it's all done. React is more just a tiny JavaScript library, and you choose other additional things to put into your project depending on your demands. Of course, it renders the page on client side. That's what it's about. So all the stuff does the browser itself, the client. And it uses a virtual DOM. That was a new concept at this time. Others use it now too, like Woo. And it has a one-way data flow. That it we'll see later. Okay, let's have a look at the virtual DOM. So let's say we have data, models kind of connected, or on the server, read from the server. Then you want to put this into elements of your web page, and normally you would create the DOM elements of your web page, but with the virtual DOM you have something in between. And this means out of your data, it will create a DOM representing the real DOM, but it's just in memory. So there's no real DOM stuff in it, just in memory. And memory is way faster than changing or doing something in the DOM itself. So jQuery, for instance, works always on the real DOM, and it has its limits then because of this in terms of performance. Okay, so we calculate a virtual DOM, and then we have a renderer who cares to transfer to this DOM. And this is a DOM for the normal web browser. There are other renderers for React Native, for instance, native iOS and Android. So it's the same here, but it just renders other things in the real world. Okay, what happens if data changes? Then React will calculate the complete new virtual DOM again. So it's a lot of work, but it's all in memory, very fast. JavaScript is a very fast language, and so it very fast can create this new virtual DOM. And if that's completed, then it just has to diff both the old virtual DOM and the new, and to figure out which boxes, which parts of the DOM are really changed, and then it writes this to the real DOM. So that's really fast because only the little changes and the real DOM has to be made. Okay, we saw these little boxes that are the components, and each component gets properties and that are data or functions. And within the component, it can have a state. That means it can hold inside the component data, internal data, and keep it as long as it lives. And then is there a render function, almost always, and this renders then the DOM, the diffs, and all the elements for the DOM then. And you have life cycles like for mounting, updating, unmounting. You can do things at this moment. And in the render function, it can call other components, and they are constructed the same way. They get props from the parent component. This can be data from the top props, or it can be a state, which is internally here in this component. And so we have a hierarchy of components, and the data flows from the top as props to the childs. Okay, how does it look like? Let's start with a very simple web page. This is my web page, a headline and 2 names. And we have the JavaScript code here, and we have an HTML index file which holds this code. To have a closer look, this is the HTML file. It just delivers one div with the ID root and nothing else. And the script where all my code resides, and if the page is called, then this bundle.js is executed, and this bundle, this JavaScript code, will then put more stuff into this area. And it does it with, that is now part of the JavaScript file, this React.render, and it calls a component app, has a headline list of attendees, and puts it, the result, into the element root. So here will be simple contents and data if this code got executed. So we called our component app, and it extends the React component, and it has the render function, and this returns a div, and within the div an h1 for the headline, and 2 components person with the name Meyer and Schulze. And now let's have a look at the person. This is another component called person, and it shows then the name. And here we'll see that this .props.name is a property which I gave the component person here. So I can define my own properties as much as I want, and I use them with this .props. And the name of the property. So that's an easy way to deliver the data from the top to the childs. Okay. This was all JavaScript. And this doesn't look like JavaScript. And this is JSX, the JavaScript extended. That is an invention of the React. And you can define here HTML text, all you want. And you can add your own components. And you'll see it easy. If it's a capital letter, then it's a component. And if it's a normal div, for instance, then it's a normal HTML tag.
Is that by convention, or is that part of the language?
That is convention. But yeah, you should. So the other interesting thing is, if you developed a JavaScript in Domino, you haven't seen such things like import something or a class like in Java. And these are new elements of the language JavaScript from 2015 called year 6. And they allow a way better development than the previous version. So, but what do you do if your browser isn't able to read this, the JSX and these new versions of JavaScript. For this, Weber comes in and it converts JSX into normal JavaScript. So under the hood, this line gets then just normal JavaScript thing with an object and so on. So it's just plain vanilla JavaScript. And the other things from ES6, there's already ES7 and ES8 out. For instance, this is async. All these things are also gets transferred into old plain JavaScript, so that the browser is able to execute it. And the funny thing is, you can develop in a future version. So even if ES9 is now some ideas, they will always gives you the converting routine that you can play with it. And if it goes to the standard, then it's just a part of the language.
Where does Babel happen?
Babel covers during the build process. On the client side, we develop. This is Babel's part of this build process.
When I load the React.js, Babel part of it.
It's more integrated in the build process, but I think you can decide if it's if Babel works on a browser itself and does it on live, or it works on during the build process and it's already converted to the old JavaScript, and the old JavaScript is developed. So yeah. Okay. So far it was easier just to show things. Now it's getting more interesting with events, how this works. So I want to add a delete button here to delete the Meyer or the Schulze. And for this, I have to do the list of users flexible. So far I put it just a name for the components with 2 people in. Here I define a state. This was a state thing in the component, that the component is able to keep data inside as long as it's lit. And this way you define this state, and I initialize it with the tag people with Meyer and Schulze. Okay, and then I define a function, delete person. It has a parameter, the name of the person, and if it's called, then it sets the state people to a new state, and this throws this person out of the list. So it's a filter, and only if it's not equal to the current element of the person, then it keeps, otherwise it throws. So this way the person gets deleted from the state. Okay, and now we give the person another prop, delete person. That's a function. So it's not data, but the function. And this component person is then able to use this function, to call this function, and yeah, to delete itself. So I have my name and a button delete with one click event, and it calls the function that was delivered as a props and gives his current prop name. And this way, if I click on the button, then this function gets called with a name and it gets deleted out of the list. Okay, let's look a further. So if I have here my component, it gets deleted, so it tells with a delete function, for instance, this component delete me. And often that's not enough. So often it's the case that another component is affected by this, maybe the number of person. So then it's already a bit difficult because I have to put the number of person or the list of person not here because then this component couldn't receive it. I have to put it up here. So it would have to be in a state in this component and deliver it down here and down there to show here the lists of the persons and here the number of the persons. And this might get very messy if you put all the props or the state up to the root. And so there's a better way. And you say, okay, then let's put all the stuff on the top level, the complete as store, complete data into the store, and from there it delivers then the data as props to the components which needed. So if I get here my delete message, then I tell the store, hey, I got deleted, and then it reduces the name from the list and gives the new properties, the new data to this components. And here I have the reduced list, and I have here the reduced number of persons. So, speaking in general, the data flows from top to down, and the events go from the bottom to the top. And there is also a tool for this, and this works this way. We have the store with the data in it, and it delivers the data to the components. The components can have actions, and if they get executed, a dispatcher gets a hint. Here's an action with a new state, and this dispatcher changes the data in the store, and as soon as here the store gets changed, React knows, oh, I have to deliver the new data to the components. And so it's a cycle, previous state, action gets a new state. And for this, there's Redux. It's another JavaScript library, and it does these things. It stores the data in a single store, so all the data which is important for all the application is stored in a single store. The state can only change by actions, which are then executed by the dispatcher. And the state is always a copy of the current state with the changes. So you never overwrite the current state. And this allows time travels. This is, we'll see later. There's another part you can use, that's the React router. So you can, if you have a single page application with all the menu entries, so this, is a React router. It keeps the UI in sync with the URL. If you put an URL in, then it knows which components are to render and what to do. And it allows lazy code loading, so you are able to load at the beginning, not the complete code, but if you choose a certain URL or in your certain menu entry, then you are able to load the part of this code into the client. Okay, and then for Bootstrap, I use Bootstrap. There are also tools available, and there's React Strap for version 4, and Bootstrap for version 3. They are completely different projects. Unfortunately, they are not compatible. So I worked with React Bootstrap, and it takes a lot of work to go to React Extract. I still hope that they one day go to version 2 forward. Maybe they are not. But you have there buttons, dialog boxes, and so on, already prepared as components, and you can use them inside, and they behave then like a real Bootstrap button and so on, with properties like primary and so on. So let's have a demo. I created, just for fun, an application where I can have a theater it simulates a theater with seats maps, and you can book seats and so on. So, this is a single page application, and I have a menu, a menu structure with different tabs for completed, and I have different theaters, so this is a larger, and I can click on a seat, and as soon as I click on a seat, it gets here into the list, and if I click on the X here, it removes the sphere from the list, and here from selected thing. And normally you would say, okay, I have to develop some observer also that this list gets to know if I click here or here, if I click here. So that could be very difficult, but with React it's very easy. You have just a single on-click event, a function which is executed, and it does always the same. It toggles between selected and not selected, and no matter where I click on it, here or there, it does the same thing. It removes or it adds a certain seat to my long list of selected seats. And okay, and then I finally decided to buy, then I buy the tickets, and they are gone here as available seats. I added also the possibility to scroll here. I added a box where I can see which seat what to which cost. And I also tried to create a larger venue. These are 4,000 seats, and now you feel it takes some time. But if you imagine it's 4,000 single seats, everyone has a rendered dialog box if I mouse over, and everyone has an on-click event, so that's a lot of data. And for me, it's still amazing how fast this works. So this was kind of an experiment before we started large projects to get a feeling how efficient works JavaScript. Okay, so the data is stored in a NSF, in a Domino database. It's I made it very simple. I have my stages. The main stage, for instance, has a name. I support 2 languages, English and German. And it has rows and so on, and it's just a bit of JSON data, arrays or objects. And I read it from there, and if I stages are static data. And then I have my shows, that is well, the description, title, and so on, also in both languages. And then I have the performance itself, and this has a connection to the show ID and the stage ID, when it happens, date and time, the prices for the different categories, and then the available seats, just a name and which category it is. So it's all. Okay. Now have a look into the development, the client development. I use WebStorm. This is a very good IDE. Costs a little money, but really little, and they have a long time experience in refactoring, for instance, is very easy. So if I have something to rename to Gerard or so, then it's all done for me. And yeah, let's start at the index.js. So we have here the entry point. So we render the app and some other thing into the root div of our HTML. Oh, that's what I want to show. The source code of this page is just this. Because that's the source code, just a div with a root and a link to the bundle where the whole code resides. And I add here a provider for the store, that is the Redux stuff here. So if I go to the app, then I have here the router included, the React router, and I define here what should happen. So, okay, on the top is my menu bar, but then it depends what I show beneath from the URL. So if it's just the the slash, then it's the home. So it means if I'm in the root, then I call the component home, and it will jump to the home component. If I have shows, then it goes to the shows, and if I about, for instance, then I have the component about. It's just a simple. Okay, and if I have a certain performance, then I have slash tickets, slash, and then the number of the performance ID. And then it calls component performance. And inside this performance, I get an property match, the props that match to params, and I get my performance ID and can work within this component then, and in this case show this certain performance. And inside here I have the seed map. I go to the seed map, and I have somewhere a map of all seeds, and they are defined here. So this is a array of my components. And every seed has a position, has a tooltip, and has the seed number, and has this on-click event, seed to flick. So it's a whole hierarchy here. This whole thing is working with Express Server, Node.js, and if I change something in the code, then I get the results right away. So I have here, for instance, a seed category is light blue. If I change it to blue, then I'll see that the get is ugly blue. And yeah, so right away you can change things in your code and see it right away in your browser what happens. And that is a very good experience for a developer. Okay, and then I have okay, and for the access to nodes, I use fetch, just call a REST call, and the Domino server gives me then the data, or I ask to change something, to book seats, also with a REST call. And on the server side, I have then a little X page. I use here as an extension library, the REST service, and I do nothing, just call my Java class, and there happens then the whole code. In real projects, I skip this REST service from the extension library and call the Java classes right away. It's a bit faster than this. This was some time, and this is called, and it does HTTP stuff. It gets the requests, looks for what to do, and for instance, if it's method get, then I do get and do the stuff I want to do, read those data on it. Okay, so that's the server part, and there are nice tools on the client side. If I have I have two development tools here. The one is I can explore the React stuff. So if I installed it, I have an React tab in the developer tools, and I can explore it, which components are here called, the grid, the row, call, the seed map, and so on, down to a certain seed. Overlay, and then I have a seed here. And I have the properties and the state, and so I can see right away what happens inside my my application, and I can debug very well with this way. The other thing is a Redux. This was a thing, the part which has a state, all the data in it, and it has here the whole history, shows me when I clicked which seed, and I even can recall the whole session, so it does the clicking for me and the looking and so on. So I can time travel and analyze what happened. I can say, okay, for instance, this seed click never happened. I click skip, and then can I look what happens then. So it's a very good way to debug things in the state.
Those are just browser add-ons?
Yes, just browser add-ons. Yeah. They work for Chrome and for Firefox. Okay, let's go back to the slides. So as development tools, an IDE, I started with Atom, it's free. My recommendation is WebStorm, but you can also use Visual Studio Code. It's getting better and better week by week. There are updates, and it's almost already the same state with WebStorm. I would say there's restriction stuff is a bit better in WebStorm, and in WebStorm I have a mode, have the shortcuts like in Eclipse, like in Domino Designer, so I have F3 for code definition and so on, and that's very convenient. I like this. So we have ESLint for syntax checking and so on. About Babel, we spoke about it. Webpack does the work and bundles all the stuff on the client side together to this bundle.js and looks for only the things used and doesn't integrate things it doesn't not used. So it minimizes the whole thing for runtime and yeah, does all the work for this. Then we have the NPM package manager to install new to install modules, components available. Facebook created John, that's a bit easier to use and more reliable maybe. And Node.js as a JavaScript runtime. So. And yeah, two browser extensions, the React developer tool and the Redux. So why Domino? It's a database, it works well. You know, we use it and all the time, and why to switch to something else? We can just use it. Domino serves also as a web server. And we have all the benefits of Domino: security, user management, cluster, replication. So that's out of the box we can use. Our customers have Domino, so it's easy for us to deploy. And we just can put all the stuff in one NSF and deliver it to the customer. And there's no more installation. It's just one NSF or NTF. And there's all in it. So on the Domino side, you need a REST service. I use an XPage, mini XPage plus Java. You can try to use Domino data service, but it's limited. So you have more freedom in Java. You can do what you want. Smart NSF is an option for Sven Hasselbach's OSGI plugin, and there are other solutions out you can use. And maybe, hopefully, it will be out of the box something soon in this Domino 10. That's even more easier to use. So React and more. There's React Native, that is the other renderer for iOS and Android that creates real mobile apps. It uses the native components, and it's not 100% compatible, so you can't just take this and run it or compile it for the mobile world, but the estimate is that's 85–90% usable code included. There's Relay, another project from Facebook, and this uses GraphQL very heavily, and this makes it for development on the client side very easy to exchange data between the client and so. But your database has to understand GraphQL and so forth. There are projects with Domino, but I don't know. So I didn't explore it yet. My hope is that it will be part of the core Domino. So we found our solution. We have a on the server side, Java with a business logic, a mini X page, and most of the application resides on the client side. So usual 85% of the work is on the client side and about 15% on the server side. Okay, just want to show one thing. If I develop my application on my head, then I start a build. And the build puts the comprehensive code into this build folder and has then this bundle JS. It's called a bit different with a hash. And all the CSS is in one place. And if I want to use this code to transfer it to the NSF, I just grab the complete folder static and put it into the NSF in Package Explorer into the web content folder. And here are the files, static files with this armor. And that's all that I have to do. Just grab it, put it into the NSF, and then it works inside the NSF. So I call the NSF the index HTML, and then it works the same way like in my development mode. So now it's completely in one NSF. My client code, my REST source, and the data itself.
You can't edit directly in the NSF. It's always a transfer process. Those files, the ones that you dragged into the web content.
You can trick with on this project and linking it, but
oh, yeah, that's messy.
Yeah, but
okay.
It's not so often
But
that I
that's
do
a function of your
work.
tools. That's a function of the tools you chose. So it's not. You could do the whole project as files in NSF if you wanted to. You don't have to use the fit. You know, you're showing us your UI tool that you used.
Yeah.
But you don't have to build the project that way.
No.
You can build them all. I think that's what you're asking, right? I mean, if
Right.
you're not using his development tools, you could just write them in the tools. And
Bill's process runs
it would just be awful. It would just.
It's
they're not good
not
tools.
really hard. Yeah.
Yeah.
Okay.
Yeah. Yes, you can do it.
It's confusing because you're showing us your development tools and environment and Agile, and React, and we're trying to separate which is the React part and which is the tools part. That's really confusing.
So the React port is the client port, and I have a build process. Then I get some files, and what I do, where I put them, it doesn't matter. I decided to put it in the NSF itself. You could create a Node.js server and put it there, and it would work the same way. So that's the client port, and I use the Domino server also as a web server, meaning that I can call this index HTML and JavaScript code direct from the NSF, but I don't have to. It could be something else.
You can see there's a compiling code and take the compile stuff and put it in there.
Right. Yeah. No, I understood that part. Yeah.
No.
Yeah.
Just curious if you always served it that way, or did you ever serve it from another web server, whether it was the Express web server or with a static web server like Apache HTTP? Did you always serve it from Domino, or did you experiment with other approaches?
No, myself, I only work with Node.js. My colleague is working with Spring Boot and put the stuff in there and created an own database. So it's Domino free version, but it takes the client port and just have to switch to another database.
I was curious. So we do React development.
Myself,
outside
only
Domino.
Domino.
We throw it straight on a web server. There's no need for the client-side stuff to go inside anything server-side, whether it's Java, Domino, whatever, but with Domino, I was just curious about the approach on implementation.
So we found a solution and benefits clear separation between client code and server code. And we can use all the great tools for client development. And the components are reusable, small enough to put it into small pieces, which are really reusable, then you can use it in the next project. And it has a high performance because of the virtual load and other things. You can try it out, very easy. Install Node.js, that's done very fast, and then install Create React App. Facebook created such an incubator. There's already prepared the stuff, which is normally difficult for a newcomer, and you just start this tool and can develop. So it's very easy. The whole demo is available on this GitHub, and you can use it from there and play with it. And on Wednesday, I have a follow-up and show how to extend it to a progressive web app, so that the web application itself is mobile, so you can add it to a home screen, and works offline too. So this application can then work without completely an internet connection. How to do it? I showed on Wednesday. So, more questions? Then, thank you.